In applications, we are often given the marginal profit, and we need to find the total accumulated profit for some interval of x values. For example, suppose the marginal profit is 2x minus 60, and we need to find the accumulated profit between x equal 10 and x equal 50. Solution. The accumulated profit is the same as the change in the total profit. So it is the difference of the values of the total profit function at x equal 50 and x equal 10. Now recall that a definite integral is the net change in the value of the antiderivative. So our difference of the values of p at 10 and 50 can be written as the definite integral of the derivative of p. Now, the derivative of the total profit is the marginal profit. And the marginal profit is 2x minus 60. So we just need to compute the definite integral of 2x minus 60. The antiderivative of 2x is x squared. And the antiderivative of 60 is 60x. And we need to find the difference at x equal 10 and x equal 50. So we are getting, now we plug in x equal 10 and x equal 50 in our antiderivative, and in both cases we get minus 500. So the difference between them would be 0. So our accumulated profit is 0. Just the final remark. We were computing the accumulated profit between x equal 10 and x equal 50. What that really means is that we are computing the accumulated profit from unit number 11, 12, and so on. You see, we are computing the difference between the total profit from producing 50 units and the total profit of producing the first 10 units. So the difference between them, that's the profit from producing unit number 11, 12, and so on. Here's a related question. Suppose we are given the same marginal profit, 2x minus 60, and this time we need to find the accumulated gains and losses on the same interval between x equal 10 and x equal 50. In the previous problem, when we were computing the accumulated profit, we were integrating the marginal profit from 10 to 50. And when we were, like, if you sketch the graph of the marginal profit, the graph of the function y equal to x minus 60, you see that for some x it's below x-axis, for some x it's above x-axis. So when we compute the definite integral from 10 to 50, geometrically, we are computing the sum of areas above the x-axis minus the areas below x-axis. The areas above x-axis, that's the gains. The areas below x-axis, that's the losses. So now our task is to find these two areas. In general, for finding the areas, we use integration. But integration, for instance, to find the green area, we would be integrating for x values starting from the beginning of the green area until the end of the green area. But the problem is that we don't know where the green area begins, at what x value. So our first step is to find the intersection of the marginal profit function and the x-axis to find this point where the green area begins. So we set 2x minus 60 equal to 0. And from here we get that x must be equal to 30. So to compute the gains, we integrate from x equals 30 to x equals 50. We integrate our marginal profit, and when we plug it into our calculator, we get the answer 400. Similarly, for finding losses, we integrate from x equals 10 to x equals 30, and we get minus 400. So we lose $500 on that interval. And note that when we so gains minus losses will indeed produce zero profit. Here's another problem. Suppose we are given the marginal revenue and the marginal cost, and we need to find the total accumulated gains and losses between x equal 5 and x equal 15. Here's again, let's interpret the question in terms of areas. So let's plot the marginal cost and the marginal revenue. So when the marginal cost is above the marginal revenue, we have losses. And when the marginal revenue is higher than a marginal cost, we have gains. So the accumulated gains would be the area sandwiched between the marginal revenue and the marginal cost. We can compute this area using integration, but first we need to determine starting this green area. It starts from what x value? So first we need to find the intersection of the marginal cost curve and the marginal revenue curve. So for that, we set the marginal revenue and marginal cost equal. So we have x squared minus 10x equal to 0. And we factor this. So we get x equals 0 or x equals 10. So now we know that the intersection point is x equals 10. So now we are ready to compute the gains. So in order to compute this green area, we write the integral from x equals 10 to x equals 15. Now, what do we have inside of the integral? We need to have the upper curve minus the lower curve. So in this, for this green region, the upper curve is the marginal revenue. It's higher than the marginal cost. And the lower curve is marginal cost. So we have marginal revenue minus marginal cost. So we need to find the antiderivative. The antiderivative of x squared is 1/3 x cubed. Now the antiderivative of x is 1/2 x squared, and times 10 we'll have 5x squared. And now we need to plug in x equals 10 and x equals 15 into this antiderivative. So the difference of these values will be 166.67. Now, when we compute the losses, we need to set up the integral from, so the red area starts from x equals 5 and ends at x equals 10. And it is sandwiched between the marginal cost and the marginal revenue. This time, the marginal cost is higher than the marginal revenue. So the upper curve for the red region is the marginal cost, y equals 10x. The lower curve will be the marginal revenue, y equals x squared. So in our integral, inside we have the marginal cost, 10x, minus the marginal revenue, minus x squared. Plugging this into the calculator, the value of this definite integral is minus 83.33. So our losses is $83.33. Finally, if you want to compute the accumulated profit between x equals 5 and x equals 15, we can either set up the integral from 5 to 15, or we can, since we already know the gains and losses, we can just subtract the losses from the gains, and we get $83.34.